So, good morning, everyone. Welcome to today's class. This is lecture number 5 in units and dimension. And if I may ask, at this point in time, we were discussing what in the last class? What did we discuss in the last class? Just to have a recap, I told you to study one night before the class so that you know what is going to happen in this class. What was the last thing we did in the last class? Can anyone tell me? Okay, the echoing class. Echoing class, what we were doing in the last class?
Unit conversion.
Unit conversion, right? That is what we were doing in the last class. We were seeing the uses of dimensional analysis. We'll try to wind up as many uses as possible in today's class. The first use of dimensional analysis was to convert values from one unit to the other unit. We had seen some examples, and I hope that you remember it so that we can move on to the next use of dimensional analysis. And I hope everyone is writing there with me. What is the second use of dimensional analysis? The second use of dimensional analysis is to find the units and dimensions of unknown quantities, unknown physical quantities that appear in an equation. You can find the unit and dimension of unknown physical quantities if the equation given to you is correct, and in most of the cases the equation given to you would be correct. So if it is so, then you should be able to find out the units and dimension of any unknown. Let us see this with an example. For example, if I had an equation W is equal to A times T. Now remember, all these alphabets can mean different in different equations, but something they always remain fixed. For example, work done here or in other equation may always refer to what will work done. What is work? What is W here? What is W here? What is your guess? W here, as I already told you, I have spilled the beans. W here is work done. Do we understand work? We have discussed the units and dimension of work. W here is work, let us say, and T here, normally whenever you see the word T, it will often, more often or not, unless otherwise stated, it will refer to time. If W refers to work and T refers to time, there is also one more unknown quantity, unknown physical quantity that you see in this equation. What one is that? Which one is that? The unknown quantity that you see in this equation. W is work, T is time. What is the unknown quantity that you see here? The unknown quantity that you see here is A. Now you'll say, sir, why is A not acceleration? As I told you, different alphabets may mean differently. So now we are asking you, what is this A equal to? You have to find out the unit and dimension
Newton.
of this quantity A. And what is the answer?
Newton.
Please
Newton.
solve it and then give me the answer. Do not guess. Remember, we are not here playing a guessing game. See how it has to be done and then tell me the answer. I'll give you a minute to think about it. Remember, W is work, T is time, A is the unknown quantity. You have to tell me what is A and your time starts now. Remember, whenever you are attempting any question in this chapter or any chapter in physics, you'll have to remember simple things that we have already discussed. And I hope you have gone through the last class. If you have gone through the last class, you should be able to remember the important formulae, important points that we discussed in the last class. If you remember those points, I will just show you on the screen for a moment. If you remember these points that we have already discussed, point number 1, I'm not going to say what was that. Point number 2, you can see on the screen. I won't tell you what was that. Point number 3, 4, 5, and 6. These are the 6 points that you will have to remember to solve any question in dimensional analysis. And just yesterday, JEE Advance happened. I have just not seen the paper. I've only interacted with students. I have not seen the paper, but I am very sure that a question of dimension analysis would have come in JEE Advance that happened yesterday. In the next class, I will tell you what question was that, because I will be getting the paper today in about an hour or so. My team is working on it. So, you remember these 5 6 things, and using these 5 6 things I'm going to solve that question. I don't know what question was there, but I'm sure that there would be a question based on dimension analysis. So here I come back again to the question that I have given you. I've already told you how it has to be solved. Now it's up to you. I'll give you a minute. Solve this question and tell me the answer. What is the units and what is the dimension of this physical quantity A? 2 minutes.
Power, sir.
Yes, beta.
Power, sir.
Per. What per? Power. Remember, I'm not asking. I mean, there would be instances where it would not be so evident. I just gave you the simplest possible question. Instead of telling me, the name of that physical quantity, because in some cases you will not know the name, and I'll give you the next question and you will not know the name of that quantity. So instead of telling me the name of that quantity, tell me the unit and tell me the dimension. That is the question. I have not asked you to name that physical quantity. No, I have not asked you to name the physical quantity. I've only asked you to tell me the unit and dimension of that physical quantity. That is the only thing I'm concerned with, because if I just change the question, you will not be able to tell me the name of that quantity. Name of the quantity does not matter here. In this question, what matters is the unit and the dimension. You might not get a question on unit in JEE or NEET. You will definitely get a question on dimension, and I'll prove it to you. Just a paper that happened yesterday. I repeat the question. What is the unit and dimension of this quantity A? And it is pretty simple, and you just have to remember what we have discussed and practice. The more you practice, the more you will be able to understand what type of question is going to come. Yes, beta, I'm waiting. What is the unit and what is the dimension? No one? It is pretty simple. Okay, I'll solve it for you if you can't attempt this. Now remember, the first point that we discussed was known as principle of homogeneity, and it tells us whatever physical quantity or whatever unit or whatever dimension we have on the left hand side of the equation. This is an equation or a formula. Whatever dimension we have on the left hand side, the same dimension we have on the right hand side. Do we remember this? On the left hand side, we have work. So whatever there on the right hand side should also be equal to what? Its dimension and its unit must be same as the unit of work. Do we understand this? Yes or no? So the unit of A into T, remember I am not talking about the value of A into T. Here the value of A into T is also equal to work done. But in the next question, it might not be so. I'm only talking about the dimension of A into T. Remember, the name of the chapter is dimension, units and dimension. I'm only talking about the dimension of A into T. The dimension of A into T would be same as the dimension of work. So from here, I can simply write the dimension of A. Remember, I'm not talking about the value of A. The dimension of A is simply work divided by time. The unit of A is work divided by time. The unit of work is joule. So it is joule divided by time. It is actually watt. This term A is actually power, but I did not intend to ask you that question. So this is joule divided by second. If I talk in terms of unit, joule divided by second is nothing but watts. Do we understand this? Yes or no? Can I have some raise hand that we understand this? How many of you were
Yes,
able
sir.
to do this? Okay. Remember, but as I told you, no one is going to ask you unit wala question. What they will ask you is dimension. So how do I get the dimension? The same way I've got the unit. So to get the dimension of A, what do I do? This is W. I write the dimension of W, work done. What is the dimension of work done is the next question. What is the dimension of work done? You will have to remember all these dimensions. What is the dimension of work done? Anyone? No one knows it. The dimension of work done is ml square t minus 2. Yes or no? Great. Divided by t, the yellow one is the dimension of work divided by t. T is time. Dimension of t is capital T. So you get the dimension of A. The dimension of A is ml square t raised to the power of minus 3. Do we understand this? Yes or no? Can I have raise hands from everyone that we understand this, sir? Simple question, simple logic. You just apply what you have learned. I hope everyone has noted down this question. It was very simple. Now I move on to the next one, which is question number 2. And I hope that you can give me the answer of this one. Remember, questions are very simple, whether it is JEE or NEET or advanced. You just have to remember simple things. So here comes question number 2. Question number 2 is P is equal to AT plus B by A times X plus C into B times T squared. Now, there are large number of terms that I have used. Don't worry. I'll tell you the known quantities and then I'll ask you the unknown ones. What is P? Your guess. What does P stand for? P stands for pressure. So I have given you one quantity. P stands for pressure. T. T stands for time. X stands for distance. So P standing for pressure, T standing for time, and D, no, not D, X standing for the distance. Then even after that, there are three physical quantities which are unknown. What are those unknowns? The unknowns are A, B, and C. A, B, and C. And the question is pretty straightforward. What are, remember, I am not asking you the value of A. No. The value of B. No. You cannot find out the value of A and B. What I'm asking you is the unit, not even unit, because that question is not going to be asked. What is or what are the dimensions of A, B, and C? I'll give you a minute to do this. Remember, it is a straightforward question. To do things correctly, if you remember things correctly, just apply them, and I'm sure you would be able to solve this one. I'll give you a minute to do this. Anyone there with an answer? How to do this? No one? Okay, let us solve it together. I hope you will be helping me out in solving this. So again, there are two things that you have to remember. The first thing is the principle of homogeneity. So whatever is there on the left hand side, whatever unit and dimension you have on the left hand side, same would be the unit and dimension on the right hand side. Do we remember this? Yes or no? Okay. Now, apart from that, now the problem here is, or the thing here is, on the left hand side we have only one quantity, but on the right hand side we have three quantities. It could be 4, it could be 5, it could be 3, it could be 1, it could be 2. Now, again, Remember what we have studied. What can you say about the unit of this block number 1? What will be the unit and what will be the dimension of block number 1? There are three separate quantities here. Block number 1, block number 2, and block number 3. Remember, we are not talking about the values of these quantities. We're only talking about the units and dimensions of these physical quantities. What will be the unit? Forget about the unit. What will be the dimension of block number 1? It will be same as what? Only those physical quantities can be added or subtracted which are same. That means block number 1, block
ML2
number
T minus 2.
block number 1, block number 2, and block number 3, they must all be same dimensionally. And their dimension must be same as the dimension on the left hand side. So block number 1 would be same as pressure. Do we understand this? Yes or no?
Yes, sir.
Similarly, block number 2 will have the same dimension as pressure. Yes or no?
Yes, sir.
Similarly, block number 3 would have the same dimension as pressure. Yes or no?
Yes, sir.
That's it. That was your hint. So now you can solve it. How are you going to solve it? A will be equal to P divided by T. Block number 1 should be equal to pressure. So A will be equal to P divided by T. P standing for pressure. What is the dimension of pressure, my dear friends? If you don't remember the dimensions, well, you will
ML2 T minus 2.
ML2 T minus 2.
ML minus 1.
ML minus 1 T minus 2. Pressure is force divided by area. You will have to remember these dimensions. If you don't remember these dimensions, well, I can't save you. Divided by T. T is time. The dimension of time is capital T. The dimension of P is pressure. Pressure is force divided by area. You know the dimension of force. You can divide it by area, which is L square. So this will be the dimension of the quantity A. You may not know what this quantity is. You may not know what this quantity is, but you will definitely know its dimension and you definitely know its unit. Do we understand this? Yes or no? Can I have raise hands that we understand this? How many of you were able to do this? Can you raise hands? How many of you were able to do? Well done. So many friends. Good. Now, once you get the value of A, you can get the value of B as well. How will you get the value of B? You look at box number 2. Box number 2, the green box. Box number 2, the green box. This box number 2, the dimension would be same as pressure. So I write box number 2. Box number 2 is B by A times X. This must be equal to dimensionally equal to P. Remember, I'm not talking about the value of these things. I'm only talking about the dimension of this thing. From here, I can find out the dimension of B. Dimension of B will be equal to P multiplied by dimension of A divided by the dimension of X. Do we understand this? I've just cross multiplied it. Yes or no? No, yes? Great. Now you can do the rest of the part. I will not be doing the rest of the part because you already know the dimension of P. The dimension of P is here. I hope you can put this. You already know the dimension of A. The dimension of A is here. You can put it from here. You already know the dimension of X. X is length or distance. The dimension is L. You can put the values and get the answer. Can anyone tell me what is the answer coming like? Something you will have to do on your own. I hope you can multiply, divide. on your own and tell me the answer. That will give you confidence that you would be able to solve this question if it comes in the examination hall. Everyone could do this. Can I move on? Yes or no?
Liquid plus 1.
You,
L
you,
square.
you can do it, no? Okay, I will move on. Let us move on to the third block. Third
M.
block is blue block. The dimension of this blue block will also be equal to the yellow block, which is pressure. So I just write the equation now. C into B into T square is same as the dimension of P. That means the dimension of C will be BP divided by B into T square. You already know the dimension of P, that is here. You already know the dimension of T or T square. T is time, so T square becomes T square. And you have already derived the dimension of B from the second equation. You use that and you will get the dimension of C. Do we understand this? Can I have raise hand that we understand this? Everyone in the bigger class, we understand this? Okay, I'll give you 1 minute to note this down. If anyone has a doubt, please ask it now. If anyone has a doubt, please ask it now. Then I will move on to some one or two more questions that will give you more confidence that you can do it. I was just checking the paper has come. The paper has come, but the formatting is not correct, so I've sent it back. There is, as I said, a question on dimension analysis and a pretty simple one. The only problem with that question is you do not know those physical quantities. I was able to see that question. That question was based on, I think, magnetic field or something of that nature, magnetic field. That is the question that I'm talking about from JEE Advanced. Even if you are not able to solve this because you don't know the quantity that is coming there, I will help you in solving that question in the next class. The formatting is not correct. I would not be able to show it on the screen. That is why I'm not showing it. As I said, everything that I say happens. So please be attentive in the class and do what I say. So I hope you have written this. Can I move on to the next one? Next question, right or no? Yes. So I move on to the third one. This is one of the most general questions. You can expect this in a NEET or a JEE Mains exam. Not so much in JEE Advanced, but this is what the question is. P into A by V square into V minus B is equal to constant. Do you know what is this equation? You must have read it in chemistry sometimes. Does anyone know what is this equation? No one knows what is this equation? Sad day. This is known as the van der Waals equation. The van der Waals correction. PV is equal to nRT. That is your ideal gas equation. If the gas is not ideal, the pressure is higher than what is expected and the volume is lower than what is expected. A and B are known as the van der Waals constant. Now you have to solve this question and the question is pretty straightforward. P, what is P here? Anyone? Your guess, what is P?
Pressure.
Well done. P, pressure. What is V, my dear friend? I have told you that this is gas law, so you must know what is V. What is V here?
Watt.
V for what? No, V is never for what. V is for volume. This is van der Waals gas equation. You have pressures and volumes coming in. P stands for pressure, V stands for volume. Then there are two unknown quantities that you see here. What are those unknown quantities? One is A, Let me color it differently. Let me color it green. One is A and the other is B. You have to tell me what are the units, not units. Units no one is going to ask. What are the dimensions of A and B? And your time starts now. And I hope you can give me the answer to this one. It's a straightforward question, as I call it. It's a straightforward question, and I hope you would be able to give me the answer. I'm waiting. You just have to apply what you have learned. That's it. Nothing else. Nothing less, nothing more. And remember, you may not know the name of the quantity that you are deriving. You just tell me the dimension, that is. I don't need the name because you may not know the name. Even I may not know the name. The easiest one in this question is probably to get the value of, not the value of B, but the dimensions of B. Remember, we are not talking about the values here. We are talking about dimensions here. Anyone? No one? Disappointed? I'm pretty disappointed if you don't know this. Simple. Help me out, anyone.
Is equal to B into constant.
Sorry, I could not catch you, beta.
Is equal to B
T.
into constant.
T.
V is equal to B plus constant.
I don't know what you're saying.
V is equal to B plus constant.
That is not the correct answer. I don't know what you're getting it. I asked you the dimension of A and B. And what you are saying is, I don't know. I want you to tell me the dimensions of A and B. I'll solve one part. I will solve the part where we can find out the dimensions of B. Now remember, what is V? V is volume. We understand this, yes or no? Now we have seen that only same quantities can be added or subtracted. Here we see subtraction. B, B for Bombay. B is getting subtracted from V. V for Vellore. Here V is volume. B is getting subtracted from V. We can only subtract same quantities or add same quantities. Therefore, the dimension of B would be same as the dimension of V. V is volume. The dimension is L cube, and therefore the dimension of B also becomes the dimension of volume. B is volume and the dimension is B. The green box. Do we understand this, beta? Anyone having any doubt, please raise. V is volume. You can only add or subtract volume from volume. Therefore, B has to be volume.
Sir, can you repeat again?
We can only add or subtract quantities which are same. Volume can only be added to volume. Pressure can only be added to pressure. Volume can only be subtracted from volume. So B has to have same dimension as volume because B is getting subtracted from volume. Do we understand this? Remember, we have written only 5 points and I will take you back to those 5 points. It's very sad to see the state of affairs that how you are studying. It is very, very sad that you don't remember these points. Point number 1, dimension on left hand side is equal to dimension on right hand side. Only same physical quantities which are added of same dimension can be added or subtracted. I also gave you this entire thing that same quantity can be added or subtracted. We have discussed this. That means that you are not following instructions. You are not studying before coming to the class, and it's a habit, a very bad one, which will lead you not to good places where I don't want you to go. So I hope that you can remember this thing. Can you remember this? Yes or no? We have just not gone into 3, 4, 5, 6, and 7. We're only doing 1 and 2. I hope to understand this, right? And in the next class, we will again go through the entire thing. Yes or no? We have already covered this much. This much. That you can do it in 5 minutes of your time. If you can give me that much of time, that much of importance to this subject, I would be highly obliged that you are giving 5 minutes of your valuable time to physics and you are aspiring to clear competitive exams which are the most difficult ones in the country. You are aspiring to clear JEE Main, JEE Advanced. Around 10, 11 lakh people sit. 1.5 lakh, 2 lakh. They clear, and only handful of them, 5 to 10,000, will get seat in the IITs. The case in NEET is tougher. 15 lakhs sit. Only a handful, hundreds get aims. Only one more handful, somewhere around 8,000, they will get government medical colleges. Rest, all of them will be in a sinking ship, paying a lot of fee. You don't want to do that. Please give 5 minutes of your valuable time, at least, to this subject, because this subject probably will take you from a private college to a government one, from a government one to the most prestigious one in the country. Can I have that much of time for this subject? Yes or no? Can I have this
Sir.
much time? Yes or no?
Yes, sir.
Please be attentive, beta. Please be attentive. Just go through the notes. That's all I ask, and I can tell you the most difficult problems you can solve from the notes. Okay, having said that, and I hope that this has given you more strength and more power, can you tell me the dimension of A? Can you tell me the dimension of A? The question is still not over. I've already told you the dimension of B. Can you tell me the dimension of A, beta?
ML5T minus 2.
Wow, I got an answer, but I'm more worried and I'm more concerned about how you got that answer. So can you tell me, beta, how did you get this answer? That's my primary concern. How did you get the value of A from this part? The part which I have put in pink brackets. How did you get the value of, not the value of A, how did you get the dimension of A from this pink part, beta? Tell me.
Sir, we know same physical quantities, same dimensions will be added.
Yes,
Uh,
beta.
And by doing LCM, we get PV square plus A by V square.
You don't have to do LCM and SCF, beta. You just say that, sir, same quantities can be added or subtracted. This quantity we already know is pressure. Why you take LCM, SCF? You are not understanding the concept. Understand the concept. Understand the concept. Understand the concept.
Manipulation, sir.
P is pressure. Same quantity can be added or subtracted. So one quantity is P. The other quantity has to be P. And the other quantity is A by V square. This A by V square dimensionally has to be P. We are not finding out the values that you take LCM and SCF and common factors and square roots. Are you getting my point, bacha? We're only talking about the dimensions. We are not talking about the values of these things. No, not values. Get these values out of your system. We are not dealing with values. We are only dealing with dimensions. Same quantities can be added or subtracted. P is pressure. Pressure can only be added to pressure. So the next quantity, which is this quantity in blue, entire quantity in blue, this entire quantity in blue has to be pressure. Do we understand this? That's it. So now I can get, remember, not the value of A, but the dimension of A, and the dimension of A will be P multiplied by V square ka dimension. It is as simple as you get. You already know the dimension of P. You already know the dimension of V. You can get the dimension of A. Can I have raised hands from everyone that we have understood this? Okay, this gives me a lot of confidence. Can I move on to the next question? I hope everyone has noted this down. Shall I move on? Life has to move on. Let me move on to the next one, and I'll give you a simpler one that might give you more confidence. F equates G M1 M2 by R square. I hope all of you are familiar with this equation. Yes or no? Familiar with this equation? So I may not tell you what is F, but still I'll tell you. F is force, known. F is force. M1 and M2 are masses. This is the formula for universal law of gravitation. M1 and M2 are masses, my dear friends, and R is the distance between them. So we know the dimensions of these quantities, which are in yellow, are unknown quantities. The only quantity which is unknown here, my dear friend, you also know what is that. It is known as universal gravitational constant, G. Now my question is pretty straightforward. I am not asking you the value of G. I am not concerned about the value of G right now. What I am concerned is the dimension of G. My dear friends, can you tell me what is the dimension of G? And it is pretty simple, pretty straightforward. Just have to apply what we have learned in the previous two classes, and you will have more time. I'm going quite slowly so that you can cover up whatever we have done in these 4 or 5 classes can be covered up in 5 to 10 minutes of your valuable time. I hope spending that time and only doing these 3 or 4 or 5 questions that I give you is more than enough. You can clear, you can solve any question that comes in JEE, Main, Advanced, NEET, whatever exam that you are appearing for. Can you now tell me the units? I'm not worried about the units. Can you tell me the dimension of G, capital G, universal gravitational constant, my dear friends?
Power -1, L power 4, T power -2.
I hope that is correct. Even I don't remember the dimensions of G, but I know how to get this. On the left hand side, I have force. On the right hand side, I have something, but that something has to be force. Same concept. So, left hand side F, right hand side G, M1, M2 by R square. Dimension must be same. So, the dimension of G, my dear friends, the dimension of G, my dear friends, will be F multiplied by R square divided by M1 and M2, both are masses, so I can just write it as M square. Are you getting me? Remember, I'm not talking about units here, I'm just talking about dimensions here. Just put the dimension of force, my dear friends. Just put the dimension of R. Just put the dimension of M. Dimension of force, F, is MLT minus 2. Dimension of R, distance, is L, so L square. Dimension of M is mass, M. square, and you will get the dimension of G. Do you get this? Yes or no? Raise hands will give me more confidence that we have got this. It is pretty straightforward. Remember, the bigger class, no one got this. Anyone got this? Can I have raised hands from everyone? Okay. That takes me to my next question. X equates A sine omega t plus phi. Oops. Now this might look like a very complicated thing, but remember, we are not going to face this equation till I think not even your 11th standard. I think waves is not in your 11th standard. It's probably in your 12th standard, but probably we have got simple harmonic motion that's coming up in your 11th standard. We will be encountering this equation in simple harmonic motion. Now let me tell you what all things or quantities are known here. X, what is X, beta? X is the displacement. If I don't want to call it displacement, I can call it distance or displacement. They have the same dimension, so I'm not worried right now. I'm only concerned with dimension. So X is known as displacement or distance. Sine is your angle. Everyone knows this. And the other quantity that I know is T. T is time in seconds. Right now, we are only concerned with the unit. We are only concerned with the dimension. We are not concerned with the units. So X is known, which is displacement or distance. T is known as time. I also see three quantities which look like unknowns to us. They are painted in green. I like green. They are painted in green. A, omega, and this again, this is a Greek alphabet, phi. Thanks to Greece and Greek people that we have got all these wonderful looking alphabets. English doesn't entice me, and the Greek alphabet does. A, Greek, A is English. This small omega, this one is known as omega. Again, Greek alphabet, omega. This is not W, this is omega. A, omega, and phi, all colored in green, are the unknown physical quantities. Can you tell me the dimensions of these quantities? A, omega, and phi. And I'll give you 1 minute. 3 minutes are left for your class to get over. You shall have 2 minutes of those. And then in the remaining 1 or 2 minutes, I will try to explain what has happened. Remember, whatever questions we are doing, we are only by the points that we have written. I think someone has an answer. Yes, Vita. Someone has an answer? I heard some voices. Whatever we are doing, we are only using these quantities, these 5 or 6 points that we have written. Point number 1, principle of homogeneity, LHS is equal to RHS. Point number 2, only same quantities can be added or subtracted. We have seen a lot of examples on this. Point number 3, different physical quantities can be multiplied or divided. Point number 4, when two same quantities are divided, we get a ratio. Some quantities are always numbers. Angle is the only quantity which has no dimension, it has a unit. Some quantities are mathematical expressions and they are numbers. If you can remember these points, you would be requiring more than one of these points to solve this question. Anyone has an answer? No one seems to have made any progress here. Is that so? I'll give you 1 more minute. The time is already over. We are running on extra time. It's same as what happened in yesterday's match. We could not finish our quota of 20 overs in the time. So over the last 2 overs, India as well as Pakistan had to face a penalty. A penalty of keeping one less player outside the 30-yard circle. We have run out of time. And I'll give you 1 more minute out of that precious time that we have lost and we are still gaining more. I'll give you 1 more minute on that.
A is equals to L. W and
A is equal to L, that is correct. What about this?
W no dimension.
It's not W, it's omega beta. Yes, omega. No dimension. No, that is wrong. Phi?
Q pi no dimension.
Phi is no dimension. A is L, that is correct. What about omega beta? Omega. This gentleman, that looks like W. It's not W. It's
No dimension.
No, it has got a dimension. Now let us go ahead and see. So the first concept you have to apply here is this entire quantity, which I have put in bracket. What should be this entire quantity equal to, beta? This is a mathematical expression, yes or no? So this quantity is nothing but a number. Yes or no? Do we understand this?
Yes.
And since it is a number, it has no dimension. Do we understand this? Dimension is 0, mass is 0, length is 0, time is 0, everything is 0. Yes or no?
Yes, sir.
So now here we have x. The dimension of x is L, length. That's the dimension on left hand side. The same must be dimension on right hand side. The right hand side I have two quantities. One is in green, which is A. The other one is in pink, which is a number. Number does not have any dimension. So the only quantity that has dimension will be A, and its dimension must be same as dimension on the left hand side, and therefore my dear friends, A will also become equal to L. Do we understand this? Yes or no? The dimension of A, it is actually known as the amplitude of the wave or amplitude of simple harmonic motion. It has the same dimension as that of L. Because whatever is after that is dimensionless. It cannot have any dimension. So whatever dimension X has to come from A. Now let us look at this blue thing. This blue thing, this entire blue thing is inside sign. It is sign of something. And I told you whatever is inside sign, it has to be an angle. Yes or no?
Yes, sir.
Entire thing has to be an angle, and an angle only has units. So it will be radian or degree. And it has no dimension. Do we understand this? Yes or no?
Yes, sir.
It has to be no dimension. Therefore, this is just a number. So now you can easily say that this phi will have no dimension. Yes or no?
Yes, sir.
But now the only thing remains is omega. How do I get the value of omega? Remember, same things can be added or subtracted. Same things can be added or subtracted. Same things can be added or subtracted. So omega t must be an angle. Omega t must be an angle. So its dimension should be 0. If I write it like this, it will just not look good. So what I will do is I will write it like this. The dimension of omega into t would be 0. So I will write it as m0, l0, t0. So now I can get the dimension of omega. The dimension of omega will be the inverse of t. So it will be m will be 0, L will be 0, but t would be -1. When t minus 1 gets multiplied by t, you will get t to the power 0, and it will become a dimensionless quantity. Are you getting me, everyone? What I have done here? Omega into t has to be dimensionless. So omega must have the reverse dimension of t. The dimension of t is capital T. Therefore, the dimension of omega becomes 1 by t, and 1 by t is t raised to the power -1. This is also known as angular frequency. or angular velocity. You might not have heard these terms. We will be hearing these terms in the coming class. Everyone understood what we have done here? Can I have some raised hands? Now, can I have raised hands from students who were able to solve this question? Okay. Well done. Well, that brings us, I hope you have noted this down. That brings us to an end of this class. What we have done, we are dealing with uses of dimension analysis. We have dealt with the second use of dimension analysis, which is to find the value of, not the value of, which is to find the dimensions of unknown physical quantities. We will continue on this quest. In the next class, we'll be dealing with more questions and more uses of dimension analysis. And also, as promised, I'll tell you the question which has come in the yesterday's exam. You may not be able to know those quantities, but I will just change those quantities, make it something which is familiar to you, and then solve the same question. Remember, we'll be solving each and every question that has ever come in any exam by only those 6 points or 7 points that we have written. On that note, I will wind up today's class. I hope to see you in the next one. And please, 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 gentle request, humble request, before coming to the next class, please go through this entire thing. What we have done, you can cover it in 5 to 10 minutes. Whatever questions you have done, you can cover it in 10 minutes. Take care. Have a nice day. God bless you all.